All right, here we have another applied linear programming problem. A painter has exactly 32 units of yellow dye and 54 units of green dye. He plans to mix as many gallons as possible of color A and color B. Each gallon of color A requires 4 units of yellow dye and 1 unit of green dye. Each gallon of color B requires 1 unit of yellow dye and 6 units of green dye. How many gallons of each color must be used to make the maximum number of total gallons? So basically here you can see we're trying to make these two paint colors, color A and color B, using different amounts of yellow dye and green dye. We want to make as much of each paint color as possible, maximizing the amount of dye that we have available to us. Okay. I think this particular example is extremely challenging to start with, in that you have you have multiple things that could potentially be your variables. Okay, so you have yellow dye, you have green dye units, and then you have gallons of color A, gallons of color B. So it's like, what should be my two variables here? Notice the question. Okay, it says how many gallons of each color must be used to make your maximum number of total gallons. All right, so that's my indication that my variables should be gallons of color A and of color B. Okay, once I define those variables, I write my constraints. Well, you can't make a negative number of gallons of any color, right? So X and Y both are going to be greater than or equal to 0. And then I can come up with two more inequalities to represent how much yellow dye is being used to make these different colors, and then how much green dye is being used. So for yellow dye, it says that color A requires 4 units of yellow dye. So 4 units of yellow for every gallon of color A. Okay. And then it says color B requires 1 unit of yellow. So 1 unit for every gallon of color B, and we only have 32 total units of yellow to work with. So it's got to be less than or equal to 32. All right, do the same for green. All right, gallon A, you're using 1 unit of green dye, so 1x. Color B is using 6 units, so plus 6y, less than or equal to 54. Okay. Now I'm going to put both of these in slope-intercept form, all right? So this will become y is less than or equal to negative 4x plus 32. And then this one will become y is less than or equal to negative 1/6x plus 9. So that's just going to help me graph a little bit easier, I think, in this particular case. All right, let's actually move these just a bit. All right, just like in our last video, I'm going to make the x-axis and the y-axis over here so that this entire grid represents quadrant 1. And I'm noticing that the yellow inequality, it's got a y-intercept of 32. So I'm going to need to adjust my scales to be able to account for that. So I think it's going to be best if I go by 2 units for each space rather than just 1. So let's make this 10, 20, 30, and 40. Same thing here, 10, 20, 30, 40. Okay. All right, if x and y are greater than or equal to 0, then those boundary lines are just my x-axis and my y-axis again. All right, and then for the yellow inequality, again, it's y-intercept is way up here at 32, down 4 spaces over 1 to the right. Keep on doing it. And then for the green inequality, y-intercept is 9. Let's zoom in here a little bit. Right there. Down 1, right 6. All right, and if we do all of our shadings properly for these different constraints, you're going to end up with right here as your feasible region. Okay, so vertices, there's 4 of them. All right, so let's list those out. And we're going to do it into a table here. All right, so they are 0, 0, 0, 9. Then it looks like we've got a 6, 8, and an 8, 0. All right, now the nice thing about this particular problem is it already gives me the objective function. I'm trying to find the maximum number of total gallons of color A and color B, which would simply be f of xy equals x plus y. All right, so plug each one of these vertices into that function. If you don't make any color A, you don't make any color B, you don't make any of either combined. 0 and 9 makes 9. 6 and 8 makes 14. 8 and 0 makes 8. Okay, so we're trying to make the maximum number of gallons, right? Which would, of course, be this value of 14. Write a sentence describing your answer. All right, there you go. So now I have a problem for you to try to practice with on your own from start to finish, okay? So it's going to take you a little bit of time. Pause the video, read through the example, really focus on identifying your variables correctly, defining those correctly, and then coming up with your constraints and then working through the whole process to solve or answer the question, okay? Pause the video, work through it yourself, and then check your work with mine.